So the topic of today's webinar is excavation with retaining wall. So let us see some of the background theory. Why do we need to perform such an analysis? As we perform the excavation, let's say we want to perform an excavation for the foundation of a building. Then as we know that as we perform the excavation, the surrounding soil may try to collapse, and thus we need the retaining wall so that we can support the surrounding soils from collapsing. As you can see in the diagram here, this is the excavation which is being performed for constructing the foundation of a building. It might have some underground floors also. So we need retaining walls for these kind of purposes. There are several kinds of retaining walls which are being constructed. Some are temporary, some are permanent, and the type of wall is dependent on the excavation type, the size of excavation, the ground conditions, the ground water level, vertical and horizontal displacements of adjacent ground, and the limitation of various structures, availability of construction, cost, speed of work, and others. So the type of excavation and the type of soil will determine what kind of retaining wall do we want to construct for our construction. In this tutorial, we are going to talk about the anchor and the tiebacks. Also, we are going to talk about the struts. So here you can see in this retaining wall, we have provided some tiebacks which go all the way into the ground so that it provides a support to the wall. And the way it provides the supports, it prevents the soil from collapsing. There can be two types of failure when we provide the retaining walls to a structure. The first failure can be of the local nature, that the wall is itself collapsing. So the vertical and the horizontal pressure on the wall is so high that the wall collapses. The second type of failure can be a global failure in which the soil mass will collapse as a whole and it leads to failure. So here in this example, we are going to model a wall and we are going to model some struts, and we will check whether the displacements are not excessive and the forces in the wall are in the range so that the wall doesn't fail. So this is the model that I'm going to construct in front of you here today. This is a 2D model predominantly, and we are going to perform the excavation in two stages. As you can see here, this is the first level of excavation and this is the second level of excavation. We are going to model a retaining wall, and we will model the fill and the weathered rock, and we will also apply a pressure load on the top of fill, and then we will check whether the displacements and the stresses developed in the wall are in range or not. So let's start the modeling of this type of 2D structure in MIDASGTS. First of all, let me get you acquainted with MIDASGTS. This is how the work window of MIDASGTS looks like. On the left hand side, we have the works tree. The works tree keeps the record of all the work that has been done in the model so far. So it will tell you what all curves that you have defined. If you want to see the curves that you have defined in your model, then you can go to geometry and you can go to curve. So here you can see that I have defined 12 different curves in this model. Basically, the idea behind defining these curves is to reduce the time of the webinar so that instead of doing the detailed modeling, I can show you more of the meshing features and the analysis features. So here you can see that I have already defined 12 split edges. If I want to select any edge, I can just select the edge from the works tree. In the analysis tab of the works tree, you can see what all functions have been defined for time history analysis or the response spectrum analysis, etc. And you can also see the boundaries and the load that you have defined for the structure. So in this manner, the works tree is a clear picture of what all work has been done in your model so far. Now let us see the definition of material that we have done in this model. The definition of material can be seen from the property inside the model option. If I go to the material option here, I can see that we have defined 4 different materials. So the first material is for the fill. and I have defined the material parameters, the modulus of elasticity, the Poisson's ratio, the density, and I have defined the seepage parameters, and the constitutive model can also be defined. Here I have defined the constitutive model for the fill as the Moore column model, and I have several other models that I can choose from. So here you can see that we can use any constitutive model, and hence any of the ground material that you want to model in Midas GTS can be easily modeled. Apart from that, we have modeled a wall, and the wall material is the structure type material because the wall will be made of concrete. So we have defined the material parameters as you can see here. Then I have defined the material for truss, which will be a steel material, and I have defined the parameters for truss. You can also define the parameters for any type of material that you want. You just have to select, have to click on add. You can either define the structure, which can be a concrete or a steel type of structure, and if you want to define the ground, you can define the ground. So let's start with the meshing. For doing the meshing, we must define a proper attribute to the meshed element. And now we will define the attributes. For definition of the attributes, we will go to Model, Property, Attribute. So basically here I will be combining the section to the proper structure element, or if I have a plane strain type of element which I'll be using for my ground, then I will assign the plane strain type of element to my fill and weathered soil. So first of all, I will define the plane type of elements, which will be fill and the weathered soil. So here I am defining the fill and the weathered soil, and now I'll define the parameters for wall and strut. So I'll define the parameters for wall and strut as the line type. Because this is a 2D model, I have modeled the wall as a line, and I'll define the type of element as beam, and I'll choose the attribute for material and property for wall. Similarly, I'll define the strut attribute, and I will define the element as truss and the material as the steel material and the property as the strut property. And now I'll define the interface element between the wall and the soil. I will define it as a 2D type of interface element. And finally, I will define a link so that I can connect the two soil masses with the help of a rigid link. So I will select the type as rigid link, and I will define the attribute as rigid link attribute. So here you can see that I have defined all the attributes for performing the meshing on this model, and now we can move on to meshing. For performing the meshing in Midas GTS, we have several options. As you can see here, we can either choose the auto mesh option, which automatically meshes the solid or the plane or the edge. We can also choose the map mesh option, which is a structured mesh. So for this model, I will be going for the auto meshing, and I will be doing the auto mesh for the planar area. For doing the meshing, I will follow a certain approach. What I'm going to do is I will mesh the whole structure in one go, and I will provide it an attribute for the fill, and then I will be creating several new mesh set, and I will include different meshes into that mesh set. So I am basically doing a global to local approach. I am modeling whole of the structure in one go, and then I will be selecting different parts at different times. So let us see how we can perform the meshing. I can define the element size. In the advanced option, I can define what type of mesher do I want. So here I want to have the loop measure. I can select the Delaunay measure or the grid measure. Now I will select the edges for the area. And I can see the preview for how the meshing will look like. So here the meshing has been done for the whole structure. Now I'll create a separate mesh for the weathered soil. So I'll go to the mesh set, I will right click and I will select a new mesh set. I will rename the mesh set as the weathered soil and I will include the new mesh into this mesh set. So I'll click on the mesh set and I will click on the include exclude items and I will select all the items for the weathered soil. So here I have selected these many mesh elements and I am putting them into the mesh set for the weathered soil. Now I have changed the mesh set for fill and the weathered soil, but still the weathered soil has the attributes for the fill. So for changing the attributes, I will go to model, elements, and I will simply go to change parameter. I will select the elements as the weathered soil elements and I'll define the attribute as the weathered soil attribute. So once I click on OK, I have changed the attributes for the weathered soil mesh set as the weathered soil, and for the fill we automatically had the material for fill. Basically you could have done it in a different manner altogether. You could have selected the fill part only, you could have meshed it and provided it an attribute of fill, but here what I have done is I meshed the whole structure in one go and then I created one more mesh set to select the weathered soil. Now I'll create the mesh set for excavation 1 and 2. Again I'll repeat the same process. I will go to mesh set and I will select new mesh set. Similarly I will select one more mesh set for excavation 2. So here I am selecting excavation 1 and excavation 2. And now I'll include the excavation mesh set to these two different mesh sets. So first of all I have selected the excavation 1 mesh sets and now I'll select the excavation 2 mesh set and I will include it into the mesh set for excavation 2. So this is how I have created the different mesh set for excavation, fill and weathered soil. Now let us create the element for the wall. For the creation of the elements for the wall, I will extract an element from the nodes and I will provide it an attribute for the wall. For that I will go to model, element, and I will go to extract element option. I will extract an edge. Since it's a 2D model, I will extract an edge. I will extract the edge from the nodes and I will select the option as 1D element from free edge. I will select the nodes. So here I have selected 11 nodes. I will select the target elements which are alongside the wall and I will provide it an attribute for the wall. So here I have created the wall. Now I will create an interface element between the wall and the soil. For that I will go to model, element, and I will go to the interface element option here, and I will create an interface element from truss and beam, and I will select the elements for the wall. So here I have selected the elements for the wall, and I will put them into the attribute for interface element. So basically here I am creating an interface between the wall and the soil. Now I will create the strut element. For creating the strut element, I will go to the create element option, and I will create the line element by selecting the two nodes. So I've selected these two nodes and I've created a strut here, and I can provide it an attribute for the strut, and I will put it under the option for strut. So in this manner my modeling has completed, but here I have to create a rigid link between the elements on this portion of the model and the elements on this portion of the model, because I have already created an interface element and a wall at this junction, but in the first stage when there will be no wall inserted, these two elements will be connected together. So for that purpose I will be modeling a rigid connection between the elements on this mesh set and the elements on this mesh set. For that I will go to model, elements and connection. I will select the type of connection as coincident link, and I will select all the nodes where I want to provide the links. And I will create a rigid link. So in this manner I have completed my meshing, and I have created all the different attributes for excavations, and here you can see the mesh set for different excavation, the mesh set for wall, the mesh set for interface element, the strut, and you can see the fill and how does the weathered soil look like. So now let us model the boundaries for this model. For modeling the boundaries, we will go to the boundary option, and we will first define the ground supports. I will put it under a name for ground supports, and I will select all the mesh set. In Midas GTS you don't need to select the outer edge mesh set, you can select all the mesh set, and GTS will automatically apply the ground support at the appropriate location. So here you can see that GTS has applied the boundary condition at the outer edge of the mesh set, and now I will apply another constraint to my strut. For that I will go to supports, I will put it under a name strut support, and I will select the support node, and I will provide it the restraint in the X and Y direction. So here I have modeled the support for the strut. Now let's model the load on this. For modeling the load I will go to model, load, and I will model the self weight. Midas GTS can automatically calculate the self weight by combining the volume to the density, and here you can see that I am providing a self weight in the Y direction. And now let's apply a pressure load on the top of the fill. For that again I will go to the load option, and I will select the pressure load. I will give it a name, pressure load. I will select the type as edge pressure. I will select the elements where I want to apply the pressure load, and I will apply the load as 1 unit, which is 1 ton force per meter. In this manner I have completed the modeling for the loads and the boundary condition. Now let us model the construction stages for this model. For modeling the construction stages I will go to the construction stage definition dialog box. First of all, I'll create an initial condition when the excavation has not started, and I will input all the elements for the soil, the weathered soil and the fill into it. And I will apply the ground supports and I will apply the self-weight. Now in this construction stage, I'm going to check on this option, clear displacements. The purpose of this option is to clear the displacement which has naturally occurred, because the top layers will provide a pressure load on the bottom layers, so there will be a deformation in the bottom layers due to the self-weight of the top layers and its own self-weight. But in actual practice, when we are going to excavate in the field, these deformations have already taken place. So for that, I will check on this option, clear displacement, to clear all those displacements which have already occurred. Now I will define the wall installation construction stage in which I will install the wall. So here I am installing the wall. So I will activate the wall element. I will drag and drop it into the activated data, and I will also activate the interface element, and I will deactivate the rigid link that I created for combining the two mesh set together. Now I'll create one more stage for excavation 1. In this stage I will deactivate the excavation 1 and I will activate the pressure load. Here I will also activate the strut and the strut support. Now I'll do the excavation 2 and I will deactivate the second excavation. So finally, after all these stages, my excavation is complete. So in this manner, you can model the construction stages in MIDAS easily by dragging and dropping the different elements to the activated and the non-activated, that is the deactivated fields. And in this way, the definition of construction stages in MIDAS is really intuitive. Now let us model the analysis case. Now I will define the analysis case for the wall interface as the construction stage type of analysis model, and in the analysis control I will select the initial stage for stress analysis as K0 condition. And now I am ready to perform the analysis. The analysis will take about 20 seconds, but I have already performed an analysis in one of the models. So I will quickly open that model and we will see the analysis results from that model. So here when I go to the post processing tab, here you can see that we have 5 different construction stages that we modeled in our model, and this is the initial step where there is no wall installed, there is no excavation performed, and we can see the stresses, the different stresses as you can see here. Now let us see the stresses when the wall is installed. You can see the 2D stresses and the 1D stresses because this is a 2D model, and the 1D elements are for the beam and the strut. So here let's see the 2D stresses. So this is how the stresses change when the wall is installed, and here you can see how does the stresses changes with the wall installation. Now let us see how does the stresses changes when we perform the excavation. So this is the first excavation that we have performed, and you can see how the stresses changes, and this is the second excavation that we have performed, and you can see how does the stress changes. Now let us see the deformations. So let me see the deformation right from the first stage. For that I will go to the first stage, I will go to displacement, and I'll see the displacement in the Y and Z direction. So here there is no displacement. Now this is how the displacement starts with the introduction of the wall. Here the excavation one has taken place, and this is how the deformation looks like, and this is excavation 2, and this is how the final deformation looks like. Now if I want to see the stresses in the wall or the bending moment diagram in the wall, then I can go to any stage where I want to see the bending moment. Let's see the bending moment in the wall in the final stage. So here I'll go to the 1D element forces and I will select the beam MY. So when I click on the beam MY, I can see the bending moment profile. How does the bending moment profile changes in the wall? If I want to see the bending moment in excavation 1, this is how it looks like. So you can see how does the bending moment in the wall changes along with time. If I want to see the axial force in the strut, then I can select beam or truss axial force and I can obtain the axial force. If I want to obtain the result at a particular place, let's say I want to obtain the this stress value at a particular location. So what I can do, I can go to the result option and I can go to the probe result option here, and I can select a node where I want to see the stress, and Midas GTS will give me the stress value. Now let me activate the mesh edge. So let's say I want to see the stress here. So it shows me the stress value here. And basically it applies a tag here so that I can see, I can revert back to this value, and if I want to see the tabular value, they are tabulated here. So this is how you can obtain the stress results from Midas GTS. If you want to obtain the splice plane diagrams, then you can obtain the splice plane diagrams also, and you can also generate the diagrams for the isosurface, for the stresses or the displacements. So this is how we have performed the construction staging of the excavation in Midas GTS. Now if you have any questions about the webinar, then please ask the question from the questions window.